Hi everyone, my name is José Luis Méndez Montes de Oca, and this is my contribution to the 33rd International Material Research Congress. I'm a postdoctoral researcher in the Institute of Physics and Mathematics in Universidad Michoacana de San Nicolás de Hidalgo in Morelia, Mexico. And this work is called Resin-Based 3D Printed Monolithic Microfluidic Devices for Micromixing and Emulsification. And well, this work is based in the idea that with the new technologies of additive manufacturing, like 3D printing with filaments or 3D printing with resin, it is possible to fabricate microfluidic devices in maybe only one step of printing or only a few steps in comparison with other techniques which require higher experimental steps and sometimes expensive equipment in each of that steps. And in this case, we are working with resin stereolithography or SLA 3D printing, which is a um, relative recent commercial technique to print figures, even artistic figures. And we consider it is possible to use this technique to build microfluidic devices. Well, understanding microfluidics as a science and technique to have a good control, a higher control over fluids inside microfluidic channels for different applications. And indeed, there are companies who sell 3D printers specialized for microfluidics, but are more expensive. And our idea is to reach the fabrication of these devices using more commercial printers and resins. There are several approaches to reach this objective. The microfluidic devices can be printed by parts, but we were looking for um, uh, monolithic designs with the idea to obtain the 3D printed microfluidic device in only one step. And this is how it looks, a CAD design. These designs were made with Autodesk Fusion software for CAD, and the slicing prior to the printing was made with the Chitubox basic version software. And this is how it looks, one of our designs. We add these lure lock connectors for tubing the microfluidic device. And it is also observed the sketch of the interior inside the body of the microfluidic device, which is a G-shaped geometry. We choose this geometry to start because its simplicity compared with another geometries or applications in microfluidics. And this is an image of the same microfluidic device cut in by slices inside the software. And this is how it looks, the channels inside the body of the microfluidic device. In here we have also the detail of the holes and channels, the connection between the channel and the lure lock connector. And well, for the printing, we used an Elego Mars 5 Ultra 3D printer with high clear resin from the company Anycubic. And this is how it looks, the printed microfluidic devices on the right field microscopy. And well, we were trying with different angles of printing, and 10 degrees was a good to have better figures. Even in artistic figures, it is known that it's better to tilt some degrees the figure during printing instead of just print the figure horizontally, in order to avoid to print flat surfaces. And due to this tilt, appear these printing lines, which looks like a stair, but it can be easily removed by add resin layer over the surface as a further treatment of the device. And we also observed that in this case, for example, the design for these channels was designed to be 400 micrometers wide, but in the reality, it was 440 micrometers. So the channels are wider than expected. This could be counterintuitive. For example, if we work with extrusion, with 3D printing by extrusion, usually if you want to print a circle, a hole, usually the diameter is smaller than expected due to the expansion of the filament, but in this case, the factor is the shrinkage of the resin during polymerization. So tolerance must be considered to improve this. And well, the smallest wide that we found to be printed without problems of clogging was 400 micrometers. Before that size, sometimes the channels were clogged by desirable resin. But well, this was good for our application. And this is how it looks, a transversal view of a channel, of a microfluidic channel. And it can be observed that the printing layers, these printing lines, and it can be also observed that the walls are not totally vertical, but there exists a little bit of curvature, which we regard that could be due to again the shrinkage of the resin during polymerization, or it could be maybe to the fact that the bottom layers must hold the upper layers during printing, or maybe a combination of both factors. And well, as conclusions, we found that 10 degrees was a good angle for tilt the fibers during printing. And we regard also as a conclusion that this technique was able to obtain microfluidic devices in an easy way and very repeatable. But as for coming work, current and future work, we are currently designing more geometries, different geometries for different applications of microfluidics. And we are also still working in the calibrations to obtain a higher accuracy in the printing, and also for the tolerances. Mm, and well, it is important to mention that this work was a collaboration with a student, which is Pedro Emigdio Garcia Gonzalez, and the other members of the group. That student mainly worked in the part of the real printing, and well, I will be happy to know about your questions. You can write here in the WOBA platform, or you can send me an email if you want, and I will be happy to read you and to discuss this topic. And I really thank you for your time.